This is the derivative with respect to x of x to the x. So I'm going to make this red so you can keep track of it. First of all, you can write the derivative with respect to x of e to the ln of x times x. That's allowed. X to the x and e to the ln of x times x are pretty much the same. So you can replace. Why would you do that? Because then you can use the chain rule. So you're going to have e to the ln of x right here times x multiplied by the derivative of the exponent with respect to x. So that's the derivative with respect to x of ln of x times x. Chain rule. So that's going to give us the following. E to the ln of x times x. All right, then within brackets multiply by the derivative. So ln of x differentiated is 1 over x. We copied the other x. I want to be clear here, like, the way I'm thinking about it is this one has gone to the bottom here just to separate them out, right? And the other x, the black one, stays, and then you're going to have the derivative of x, which is just 1 times ln of x. So that's the product rule on the brackets. Now back for this step on the left side, e and ln are inverse functions. That means you can cancel them off like this. Like this. So that means all you have left is just the x raised to the x. And then within brackets, you're going to have this. These two things cancel here. So you're going to have 1 plus just ln of x. For the other approach, you're going to get the same result. It looks a little bit different. So y equals x raised to the x. Take the natural log on both sides. So ln of y equals ln of x raised to the x. Maybe keep track in some fashion. This is going to be ln of y. On the right side, you're going to have that down by the power rule for logs, ln x. Now, you can differentiate implicitly. So derivative ln of y is 1 over y times y prime equals... Okay, so that's going to be the derivative of the red x, which is 1 ln x, plus keep the x. The derivative of ln of x is 1 over x. This way. So it's going to give you... Now, incidentally speaking, on the left side, you have y prime over y. That's the relative rate of change. That single step actually tells us something, but let's move on. So it's going to be y prime equals y multiplying ln x plus 1. This over here, again, just to emphasize, is canceling to make a 1. So you're going to have y prime equals, and y was equal to x to the x times ln x plus 1. So you get the same results, slightly different looking approaches. Here's the work on both. If you like it, it's helpful or insightful.